You're listening to the Autism Weekly podcast. Each week we share community voices and bring light to stories that increase awareness, acceptance, equity, access, and inclusion. If you haven't already, subscribe to join the Autism Weekly family. I'm your host, Jeff Skibitsky. This week, we're joined by Dr. Marilena Griguoli, a neuroscientist whose research is helping us understand something that sits at the very heart of autism: how the brain processes social experiences and builds social memory. Dr. Griguoli's work, funded by the Autism Research Institute, is looking at the specific brain circuits involved in social behavior and how they can be supported. Social connection is one of the most meaningful and complex areas for autistic individuals and their families. Today, we're exploring what the science reveals about why. Dr. Griguoli, welcome to the podcast.
Thank you, Jeffrey, for this kind invitation and for giving me this opportunity to talk about my research.
Well, I think that the research that you're doing is so informative, and I think it helps families, practitioners, and individuals who are doing self-exploration. It helps all three groups really to be able to come together and to kind of really understand and process the information. But before we go there, one of the things I love to be able to get an understanding of is what drove somebody to do this research. Where did your interest in the brain and autism come from?
So it started a long time ago. Since I was a biology student, I got very fascinated in understanding how our body works. And so I really studied strong enthusiasm of physiology. During the late phase of my university education, I got interested in neuroscience and in particular in the study of brain. And this led me to be enrolled in a PhD program in neuroscience, where I immersed myself in the study of neurons, in neurons physiology, so the principal cells of our brain, and their remarkable electrical properties that allow us to think, to move, to store memories, and experience emotion. So as my scientific interest evolved, I got fascinated in brain development, which many species in the animal kingdom are born with an immature brain, and after birth, this brain continue to develop and make this process, of course, is highly susceptible after birth to environmental changes, to biological influence. And when I realized this, I thought, well, now I should also focus on atypical development of brain that can contribute to neurodevelopmental conditions such as autism.
Mm-hmm. And I mean, just thinking about going back in time of when I was in my studies is that not only is the brain fascinating, it's extremely difficult to understand the processes and, you know, how thought is developed and how our behavior comes from a lot of these experiences and how that works. But I guess a concept that I'd love for you to be able to create a foundation for us with is the idea of a brain circuit or electronic traces or however we're going to refer to it, because that I think is so important for understanding social behavior, is really understand how the brain is processing information. Can you give us a little bit of background on that so that our audience can hit the ground running?
Yes. So basically, the unit of how that allow the brain to work is the neuron, and then of course there are supporting cells. But these neurons organize in a module that are called circuit. So neural circuits are made by neurons that are interconnected and that communicate with one another to generate and regulate specific behavior. These circuits are not confined to a single brain region. Rather, they often span and overlap across multiple areas in the brain. And it's interesting because circuits appear to be particularly affected, especially those involved in social behavior, communication, motor coordination. And so one of the challenge for neuroscience is to understand how these circuits work in physiological conditions, but also in development, because this will give us information. We will add a lot of information about our knowledge on brain development, and of course can help autism research in finding a solution to help autistic people.
Well, let's talk about a little bit that research, because I mean you're dedicated your time, your energy, and your knowledge to being able to inform others. But when we're talking about social memory, and I guess breaking that down into plain terms, how does social memory work for a typically developing brain, and what would be different in somebody who is neurodiverse in the way that their brain might be processing this same information to develop social memory?
Yes, so by definition, social memory is the ability to recognize and distinguish between someone you have met before and someone new. Previous studies have shown that autistic children often experience difficulties in recognizing and memorize also familiars. So there are some studies that link this to, let's say, difference in memory processes. So not only social memory, the social sphere, but also other type of memory are different. But this is not clear, and there are not enough data regarding this aspect. What my research would like to give a little step forward in understanding what are the neurons that are involved in this process and what is different in autistic children. I think the key is to study it during development because, as I said before, we need to understand how neurons connect, this connection works, and whether there are defects or simply different connectivity. Because recent studies, for instance, have shown that according to different genetic background, you can have an hyperconnectivity or an hypoconnectivity that then is linked to several behavioral outcomes. And so understanding these variants is really important, and understanding the developmental path that neural circuit follow typical or atypical development is really crucial, I think.
So how much of this is coming from somebody who is neurodiverse or identifies autistic being more engaged or interested in different environmental stimuli versus being interested in the people in their environment? Is it kind of go to what is the salient stimuli in that person's environment, or is it that somebody hasn't built up the neural pathways when they are making those connections?
Well, the view in autism research is completely changed regarding this topic, in the sense that earlier studies in autism, you have lack of interest in social interaction. This view actually recently changed because autistic people are actually interested in engaging interaction. It's just, as you said, probably the way in which they process social information and they perceive social interaction is different from a typical behavior that we think is typical, but is just different. So I think the core now is to understand this new way of perceiving social interaction and find a common way to interact with them. So for sure, it's not about lack of interest in social cues, let's say, but it's probably just a different way to process social information. And we need to understand how we can go in their world in this sense.
Okay. And as you've gone through the research, it sounds like you're uncovering a lot of really valuable information. But has there been a thought to being able to really enhance or reinforce neural pathways that maybe, I don't know if the term would be underutilized, or if there's a process that helps to strengthen the ability to kind of create this connectedness?
So if I think about the system I'm studying, we didn't go to this system yet in detail, but for instance, the neural circuit that I'm studying, that is called cholinergic system, is made by neurons that release acetylcholine, which is a neurotransmitter and neuromodulator in the brain. And these neurons send the information through different brain regions. What I'm finding is that in some genetic condition, these neurons show vulnerability. So I find that are less in number and they do not work, but they have kind of dysfunction in the electrical property that we were mentioning as a part of an electrical circuit, let's say. So what I'm thinking, if I have to think about potentiating them, maybe there are strategies to reinforce their activity, to intervene during the early phases of development to avoid this decrease in number. But this, of course, needs to be I'm talking about very preliminary study that we are going to publish soon, but then they will need to be confirmed in other genetic backgrounds, other models, and before going, of course, to a clinical perspective. We are talking about basic science, but still important to understand the behavior and then, of course, try to improve in a way, but this is the future. Then I don't know if there are also possibility like cognitive that can also help this circuit in reinforcing. So this could be another way, but this is something that we still don't know.
Well, I mean, just even being able to identify some of the thought changes of something being more behaviorally interest oriented versus genetic biological, it gives a different starting point, even if you are going to enhance the future is if you're trying to empower somebody to be able to utilize all of the components of their brain in the way that's going to make them feel most empowered, is that's probably going to have a treatment or a rehabilitative process to it down the line. But it's nice to know where it's starting from so that you're actually working on the right things through that process. And even behaviorally, it takes practice. It takes the muscle movement. It takes building these interchanges within the brain and these electronic traces to be able to establish and to strengthen. I think that you had mentioned the axioms and being able to kind of create a better neuropathway. All of that takes work. You're developing a muscle. So what surprised you the most? Because this sounds like it's relatively new research that could drive a lot of decision making going forward. But as you've been working on this research, what are some of the things that have come up where it's been a light bulb moment for you?
So the fact that some points in the brain that are more vulnerable, and we have to understand whether genetic or environmental factor can be responsible of this or in a later stages of life.
Mm-hmm. And then the first step is oftentimes being able to understand. But where would it or could it go next? I mean, so once you get an understanding, are you talking potentially there might be a mixture between the therapeutic world and precision medicine and everything else to try and figure out, how can we work best with each individual?
Takes time. So first of all, we need to understand the biological mechanism behind social behavior and how it may differ from autism. This, of course, will not lead to an immediate treatment, but maybe we will have more targeted and evidence-based intervention. But of course, this, as I said before, will need to be validated across different genetic backgrounds. Of course, for the message for families is indirect and long term. So we need to understand really the basics, how the brain works. As you said, brain is a challenge organ because it's difficult to to understand because it's complex. It's not easy to make intervention in the brain, especially with humans. So it's a long-term study, but I think it's a step toward a better intervention in terms of cognitive approaches.
Is there any preliminary indication that if you were to identify areas within the cholinergic system that are at deficit, that potentially being able to strengthen them at a younger age changes a developmental trajectory? Could you make that leap as you're going forward, say, hey, this is something that the research is indicative of?
So this is my guess, that we need more and more to try to find either convergent or divergent mechanisms that goes, from biology to behavior and to circuit to behavior. So.
Well, and when anybody's doing research, is that one of the biggest and probably most important things is that you have people that are willing to participate. You have folks that are able to pay it forward, because this might not be something that is going to immediately be affected to your life or your child's life, but it could affect so many people that are going to have similar experiences down the line. Where can families learn more about the research, and where could they potentially go if they want to enroll in studies or be participants so that they can help to educate or provide more information, so that the future has more to work off of?
Okay, yes, I think this is a very important point, because I think science should be closer to general public and to families. And so to do this, I think the one of the best resource is to look at the literature, meaning articles published from scientists. So not the original articles, because these are very complex in terms of technical details, in terms of analysis of data. So I think this is for specialists. But the scientific journals have some sections, some articles that are called reviews or perspective, and these are summarizing the last, discoveries. And in the same time, they have both a language that can be understandable, and also they summarize what are the main findings of the study. So I think this is a good way to approach with a more scientific the findings. Then, of course, it's also important to follow maybe the websites of prestigious universities that are dedicated to autism research. Take care about the communication, and you can find easily find information that have a plain language. Another way is to follow researchers that are, some of them are good in communicating science, and you can find their podcasts as you are doing, or social media. What I suggest to do not do is, sometimes by looking at the regular newspapers, sometimes they exaggerate in reporting some findings that are actually not reported correctly. But this is maybe, it's due to misunderstanding between journalists that can want to simplify, but simplify too much or overstated something, and the scientist that maybe is not so good in communication. So pay attention to what the newspaper sometimes gives some misleading information. So like about a new fabulous therapy. This is not only about autism, it's about disease in general. And I think we should stick to science. Maybe also tell scientists that they are not good in communicate science, and improve that skill. But looking at scientific journal at the perspective or review version of articles, I think is a good way to get more close to what we are really doing. Good research needs to reach a solid point, because from that, for instance, as I said, basic science needs time. If you have a solid basic science, you can build up a translational approach that maybe will have a good impact. But many research, preclinical research that are not solid, leads to a failure in the clinical trials.
I appreciate the thought that you have of, people need to be more informed, and they need to be able to digest some of the research that's out there. And there have been advances when you're talking about the accessibility, whether that's utilizing it's not foolproof, but utilizing AI tools to be able to get a summary of specific articles so that you can get a real digestible, because we're not all speaking the scientific language, but having a concept or something broken down, it gives you a little bit more to be able to start your process with, to start your journey of educating yourself. And you're still working off the same articles. I used to be so hesitant to tell families, oh, well, go read this article. But now it's become a little bit more where everybody can access some of the information on a regular basis. Now, as somebody who has been doing the research at the deepest level and has been looking at the brain functionality and really trying to understand the social components and the derivation of these social components with autism, what is the message that you want to leave families with? Because it's something that maybe we don't all completely understand yet.
So autism is not a single deficit, but is a different developmental part of the brain. And we don't need to correct it. I mean, we don't need to normalize. We need to understand how it works and possibly intervene in a way that will facilitate communication, learning, social interaction. We have to be aware of this and try to understand the mechanism, and if there are convergent mechanisms, divergent mechanisms, and how we can intervene to help just to ameliorate the aspect of communication.
Well, Dr. Griguoli, I do appreciate you giving us your time today. I feel like I was educated on some components that I'd not been introduced to myself. So I love the fact that there are guests out there who are always looking at it from a different angle and helping to inform and searching for answers. So I do appreciate you giving us your time and joining us on the podcast.
Thank you. Thank you very much. I'm happy to.
Thank you for listening to Autism Weekly. We hope you tune back in next week to learn more about autism in the real world. Autism Weekly is now found on all the major listening apps, including Apple Podcasts, Stitcher, Spotify, Amazon Music, and more. Subscribe to be notified when we post a new podcast. Autism Weekly is produced by ABS Kids. ABS Kids is proud to provide diagnostic assessments and ABA therapy to children with developmental delays like autism spectrum disorder. You can learn more about ABS Kids and the Autism Weekly podcast by visiting abskids.com. Thanks for tuning in. See you again next week.